Alrighty, this is going on page 90. So this whole first page starts with recall. That means, hey, remember when you did this before, like in 6th grade? Okay. Plus, it is stuff that through ALEKS the last couple days you've looked at again anyway. So, but it's stuff you should have already known. All right. So the circumference of a circle is expressed by C equals what?
What? Wait. Pi r squared. No, it's
Oh, thank you. 2 pi r. There you go. There's circumference. Okay. Or what's another way? Pi d. Okay. So either one of those works for circumference. You have to know that. That's old business. Don't expect anybody to be telling you those things anymore. Although both of them work, most of what you do with circles revolves around the radius. So this one really is going to be the more common one that you see and that you would want to use for things, because you're really rarely going to have to just find circumference anymore. Like, we're kind of past that. So to use it for things, usually 2 pi r, but it's not that pi d is bad because 2 times the radius is the diameter. All right, and then the area of a circle is expressed by A equals what? Pi r squared. You absolutely have to know those and not get them messed up, okay? So then we are going to find the measurements in circles. So example 1 says find each measurement. So what we're looking for here is the area of the circle, of circle P, in terms of pi. All right, so we've already talked about in terms of x a few times. If my answer is in terms of x, what does that mean? X in the answer. So why in terms of pi is so confusing, I don't know. You know what it means in terms of x? In terms of pi means what? Pi is in the answer, right? You're not using 3.14. 3.14 goes in the trash can. I don't even want it to be in my classroom. It makes my skin crawl that ALEKS was using 3.14. Why they would do that in a high school textbook, I have no clue. But clearly whoever's writing this doesn't teach high school, I guess. I don't know. But no, that goes in the trash can. 3.14 is an estimation. It's actually a bad estimation. To be successful in upper level math and science, it's all about accuracy, okay? So the only way you are going to use pi, unless it specifically says like it did in ALEKS. I mean, if it says that, you have to use it or you're not going to get the answer they expect you to get, right? But if you have something that specifically tells you what to do for that one problem, you do what it says. But in general, forever and ever, amen, you either leave it in terms of pi, which means pi is in your answer, or you use the pi button on your calculator. And those are the only 2 ways to do it. Okay? Does that make sense? Because accuracy, that 1,000th of a decimal place there, that could kill you on on your grade. If you're off by just a little bit, no matter how great your skills are, you're not going to get credit for those answers. So you got to make sure that we're accurate. All right. We went in terms of pi. Now, what is the radius in this question? 8. Okay. Do you know the difference between the radius and the diameter? Yes, I know you do, right? Obviously, you do. That's not a hard thing. You've known for a long time. You ever use the wrong one by accident? Yes. Okay. That is the most common mistake with circles, is not using the radius when you're supposed to use the radius. And it's not because you're stupid and you don't know the difference. It's because it's easy and you're not really paying attention. It's one of those careless mistakes that frustrates you afterwards. And you're like, dang it, I can't believe I did that. So I would suggest anytime you deal with a circle, anytime, and you actually write down what the radius is, because you're going to be flying through the easy ones and using the wrong number sometimes, and you don't want that to happen. All right, so we're looking for the area. Area is pi r squared, so we write down the formula always. That could be worth a point on a free response question. You don't know when it is and when it isn't, you should always write it. Write your formula, then substitute in, and then solve it. So the next step is to substitute in everything we know. Area is equal to pi times 8 squared. Right? So what's 8 squared? 64. So my area is equal to 64 pi, because I'm supposed to have pi in my answer. Right? Pi goes last. And then what would my units look like? Centimeters squared. Good. And there you go. Uh-huh.
Would it be wrong if you put
No, it's not wrong. If you put, her question is it wrong if you did this?
Yeah.
Okay, no, that is not wrong. They're just not necessary, so I don't put them. If it was something where you had to type it in, which you would never type it in at that spot right there. Even if you typed that in on the calculator because you were trying to get a decimal answer, it's going to give you the same thing. But like here, if I put parentheses around the 64 or the pi, technically the answer isn't wrong, but Schoology is definitely going to count it wrong. Even the textbook thing would count it wrong, just because they're not necessary. Does that make sense? But it's not wrong, not at all. Okay, it's a good way to depict multiplication sometimes. Does somebody else have a question? I thought I saw another hand. Okay. All right, so then next one says the radius, so I'm looking for the radius of circle J with this area. So I'm using area again. I'm going to write down my area formula. It's equal to pi r squared. Then you substitute in everything you know. This time we know the area. It is 24 pi. That's equal to pi r squared. Well, I'm going to need the radius, so can I go ahead and take the square root of both sides? No, not until r is by itself. Would I subtract pi? Divide it, right? Because the opposite of multiplication is division. Don't tell me here you're going to cancel out the pi's, because nobody gives you the license to go and be able to just cancel things out. The reason they end up canceling out is because you are dividing both sides by pi, right? So they do cancel out, but it's because you're dividing by pi. So then r squared equals 24. So r is the square root of 24. Is that a perfect square? No. So what do we have to do? Simplify. So what does r equal? Good. 2 square root of 6. And what would my units look like? Inches, or inches squared? Inches. Good, because it's just the length there. I am. I was testing you. Because I've heard inches squared all day long. Because we're thinking area. Well, yeah, we were using area, but that is not an area. We good? Yes? All right. So now we are looking for the circumference of circle Q. So my circumference formula is, in order to find the circumference, I need the radius, right? And then, but I don't have the radius. They gave me the area. Can I use the area to find the radius? Yes. So I'm going to write down my area formula. It is pi r squared. I substitute in everything I know. So that's 9x squared pi. That's the area. That's equal to pi r squared. So what do I do next? Good. Divide both sides by pi so that those cancel out. So I get 9x squared equals r squared. So r equals the square root of 9x squared. So what does r equal? 3x, right? Square root of 9 is 3. Square root of x squared is x. So that's my radius. Am I done? No, I got to substitute it in right here, right? Because that's what I'm actually looking for. So my circumference is equal to 2 times pi times the radius, which is 3x. So 2 times 3 is 6, right? So 6x pi. And then what would my units look like? Meters, right? Because circumference is like perimeter. And I could, if you think about it, you could take the circle and you could like break it and then lay it out straight and measure it. Okay, so if it's a linear type measurement, then the units are just normal units. Everybody good? Okay, so that's a quick review of circumference and area, stuff that you have already learned, you know, combined with some algebra stuff, which you've, I'm sure, done some questions like that anyway. But all right, so now we're going to look at arc. We have talked about arc measure. Now, arc length popped up on your initial knowledge check, okay? And so I had somebody say to me when they got to that question, they said, all right, well, I know that the arc, like this arc measure, whatever it is, so let's say it's m degrees, it's the same as this angle. Is that true? Yes. Okay, so it gave you the angle measure of like 140 was the question she had. And so when it asked her for the arc length, well, 140 is what she was trying to put. She said, but it's asking me for units. Like it wouldn't let her put degrees. It had like feet, inches, whatever, and she was confused. And I said, well, that's because we haven't talked about that yet. And it's arc measure is different than arc length, okay? So arc measure is what we've already done. It's measured in degrees. Hasn't changed the fact that the central angle has the same measure as the arc does. But then arc length is a different way to look at it. Please stop doing that. You're just dulling my scissors. So let's think about this as a circular track that I could run around, okay? If I run from A to B, I'd more likely be walking, but I go from A to B somehow. So I'm going from A to B. If my circle got bigger, would the distance I have to run get bigger? Yes, the distance would get bigger, right? If the circle got smaller, then the distance I would have to run would get less, right? But what about the arc that I run? Let's say this was, I know it doesn't look like it, but let's say this is 140 degrees. If my circle got bigger and I'm still going from A to B, would I still be going 140 degrees? Yes, because whether my circle gets bigger or smaller, the number of degrees all the way around the circle is how much? 360. But the distance all the way around the circle, what's that represented by? What do we call it? Circumference. The distance around the circle is the circumference, right? And bigger circles have a larger circumference. That makes sense, right? Because there's more of it. It would be more of a distance when I run. So the distance is the length, which again kind of makes sense because it's how we think about length. But then the measure is out of the 360. Okay, so two different ways to look at the arc that are related to each other. So the measure is always out of a total of 360 degrees. The length is always a piece of the whole circumference. So think about it. Okay, we've got the measure out of 360 and the length comes out of the circumference. What kind of relationship does that sound like? Piece out of the whole, piece out of the whole. What is that? A proportion, right? Isn't it just a proportional relationship? The amount of the amount that I take of the 360 has to be related to the amount I take of the whole circumference, right? So let's say I ran halfway around the circle. Well, I ran 180 degrees, right? Isn't that, and 180 over 360, isn't that 1/2? Wouldn't I have also run half of the circumference? So do you see how those fractions are the same? The fraction just depends on what you're taking it out of. So it's a proportional relationship. The measure of the arc, whatever it is that we already know how to find, out of 360 has to be equal to the arc length, which is out of 2 pi r. Anytime you can make something a proportional relationship, that's the way you need to do it, because y'all are good at proportions. You've been doing them forever. They make sense to you. You can solve them. No big deal. Okay, does that make sense to you? You see that relationship there? Now, there is a formula, which I'm going to show you what I'm going to give it to you. Or I'm never going to use it, but I'm going to show it to you, because if you were to look it up in the textbook, that's what it's going to show you. If you were to click on worked example, chances are pretty good, because it's coming from the textbook, that they would use the formula. There's nothing wrong with it, except that it's just another formula that you have to remember. So here's the formula. And it looks like this. So I do want you to write it down. The arc length is equal to 2 pi r times the measure of the arc over 360. So again, there's nothing evil or wrong about it. If I only ever had to find the arc length, then whatever. If I can remember formulas, good for me. But let's say I give you the arc length, and I give you the radius, or even the circumference, and I'm looking for the arc measure. Then this would be my unknown. I could substitute all this in, but then I'd have to work backwards and get that out of there. Does that make sense? Which is doable. It's not like y'all can't handle that. But if I'm looking for the same thing here, do you see how it's just a different piece of my proportion? And when you set up things as a proportion, whether this is my missing piece or this is or even this is, it just changes how you cross multiply, and it's a piece of cake. Okay, so it really does simplify your life. My suggestion here, my opinion, is that this is yuck. And I suggest that you use this instead, because that's what I will use. That's not how the textbook shows you. So it's probably not how your worked example. Nothing wrong with using the formula, but I'm not going to give it to you, so you have to know it. And I think you're way more likely to remember a proportional relationship than you would some crazy random formula, which isn't random, but I know it seems random to you. Because really, just to get that, all I have to do is multiply both sides by this amount. That's where it comes from. So the formula comes from the proportion anyway. Just use the proportion. Way easier. Okay? We good? Okay. All right, so let's try this. So this says, give your answer in terms of pi and round it to the nearest thousandth. So the rounded to the nearest thousandth part, you need a calculator for. I didn't have you get them today, though, because I want to make sure that we can work through the non-calculator stuff right together first. And then I'm just going to give you the decimal answers, because I'm pretty sure you can push buttons on a calculator. Okay. All right, so we're going to start by writing down our formula. So the measure over 360 is equal to the length over 2 pi r. So I'm looking for the length of arc CD. I need the measure of arc CD. Do I know that? Yes, it's 90. The radius is 10, right? So I need the circumference. I'm going to come over here, and my circumference is 2 pi r, so it's 2 times pi times 10, which is just 20 pi. So now I have the 20 pi, which goes here, and I know they gave me the measure, which goes here, and I can go substitute it in, all right? So this gives me 90 over 360. That's equal to the length over 20 pi. So to get the exact answer, I would reduce before I cross multiply. I can knock out these zeros pretty easily. Then I've got 9 over 36. Can I reduce that? Yes. What does that reduce to? 1/4. Bless you. So 1/4. So now when I cross multiply, I'm going to get that the length is equal to 20 pi times 1, which is 20 pi, divided by 4. Can I reduce that? Yes. What does that give you? 5 pi. Yeah, gives me 5 pi. 5 pi, and what would my units be? Feet. Okay, so this is my exact answer. Now I told you 3.14 goes in the trash can. And 3 is an even worse estimate, but it's a good way to actually estimate and to get reasonableness of an answer, right? So if I know pi is a little bit more than 3. So my decimal answer is going to be 5 times a little bit more than 3, which means shouldn't my decimal answer be a little bit more than 15, right? So now you have an idea of what a reasonable answer is. So if you get 100, something ain't right. Plus, if you looked at the other numbers, that would probably make you think something isn't right anyway. But even if you got like 20, just as, 20.387 or whatever, I just made the number up, that still should make you think something's not right, because it really should be pretty close to 15 and be more than 15. So if it's less, something's wrong too. But that just kind of gives you a good way to estimate it. Or even if you're estimating it because you just need to figure out how much of something you need to buy or whatever. So 5 pi feet, and as a decimal, so in my calculator, I would type 5 times, and I push the pi button. No typing in decimals, okay? And it is 15.708 feet. That is the arc length. This is your exact answer. This is your estimated answer. I don't know why some of you have such a hard time understanding the difference and you think this is your exact answer. There ain't nothing exact about this because we had to round numbers to get it. Okay, maybe you don't know what the word exact means. I don't know. The exact answer is the one that makes you look like a crazy person at Home Depot, right? Not your Home Depot answer. All right. Yeah, I need 5 pi feet of that, please. Yes. All right. So now we're going to do this one. We're going to write down our formula, and then I'm going to have you set it up. Measure over 360 equals the length over 2 pi r. So I want you to find your circumference and get the initial proportions set up, but don't even reduce anything yet because I want to talk you through a different way to look at it. After you set up your proportions, stop right there. So can we all get there okay? Good, that's how we set it up? Okay. So we're going to start by reducing before we multiply. I'm going to knock out the zeros again. Now, I know that we could reduce 4 over 36. I know we could. What would it reduce to? 1/9. Okay, but we're not going to right here for a reason, because I want you to see another way to handle it. Because in some instances, you're not going to be able to reduce this fraction to where this numerator is 1. Like you still may have a number up there. Or even if it does reduce, sometimes you don't notice that it reduces, right? Until it's, later on down the road and you reduce it a different way. So when you're cross multiplying here, unless you know for a fact everything is reduced all the way, I would suggest when you multiply that you don't actually multiply. And I'll show you what I mean by that. So the length is equal to, and then I'm cross multiplying, right? So when I do that, I'm going to write it down like that. 12 pi times 4 over 36. I know you're completely capable of multiplying 4 times 12. I get it. But don't do it. Because what happens is you get bigger numbers to then try and divide back out. And especially when they are actually larger numbers than that and they're kind of obscure numbers, you've just multiplied things together and made it a bigger number that now you have to figure out factors for. This still means the same thing, right? Not my final answer, obviously. But at this point, when I go to reduce things, I can still reduce the 4 and the 36, but can I reduce the 12 and the 36? Yeah, 12 goes into 12 once, it goes into 36 how many times? 3. So now what I'm left with is 4 pi thirds, and I can't reduce that anymore. So do you see how it made the reducing easier than if I actually had 48 over 36 right there? It's just already split up for you. So you need to learn how to handle things like that when you don't have a calculator. And I really am afraid that most of y'all don't practice without a calculator enough when you're not in here. You grab it because it's quicker and it's easier and you always have it, which is fine, and I can't stop you from that anyway, but you do need to practice the number sense stuff a little bit and you'll get better at it. And yeah, always go and double check yourself with a calculator. I'm fine with that, but you need to practice that brain strategy. And what would the units look like here? Okay, so I want to show you this. So what we ended up doing was I knocked out the zeros, which is easy reducing. I don't know that I even count it. You're not always going to get to knock out a zero, but sometimes you do. And then really I technically just reduced once, right? If I had knocked out those zeros and then reduced it to 1/9, and I got this, which is what I'm sure some of y'all were wondering, why the heck did we just do that? Well, then when I cross, and there's nothing wrong with it, but when I cross multiply, that's going to give me 12 pi over 9. And then I have to reduce again to get the 4 pi thirds. So really I reduced twice, where this way I only reduced once. Okay, so just a different way to look at it. This isn't wrong, this isn't bad. I just wanted you to see when you multiply, you don't always have to actually multiply. I would leave them separate. Yes, sir? Sure. Oh, well, because I kind of skipped a step. So his question is, so basically, why didn't I multiply these two, or either way. Like here, why didn't I do 36 times L equals 12 pi times 4? Is that what you mean? Like these two times those two? Okay, because I can, but then what happens to get L by itself? You divide by 36, so I kind of did it all in one step. Does that make sense? I basically just skipped a step. Okay, which is okay because we set it up, right? And then you solve it. And if you skip some steps when you're solving, as long as you're not making mistakes and you're doing things legally, it's okay. If it makes you feel better to do this and then divide, that is absolutely fine. Like there's nothing wrong with that. I would actually suggest doing it more this way if there's more than one term when you have to distribute, because that's when y'all start to make other mistakes. I would definitely do it that way, or at least make sure your parentheses are there. But either way, it's fine. It's the same thing. That's a good question. Okay, anything else? All right, so then 4 pi thirds as a decimal. So on your calculator, 4 times pi, the pi button, divided by 3, and you get 4.189 meters, and that is the length. So these two things are your answers. In Schoology, you don't have access to the pi button like you did in Alex. I wish Schoology would get on board, but maybe eventually they'll get there. So instead, you can't type the pi button. I can, you can't. It's just weird. But so you have to use the word pi. And this was in your how do I type this into Schoology, but it's been a long time since you did that, and I don't know that we've typed pi in since then. So 4 pi divided by 3. That's what it would look like in the meters. So it's still how you would type this in a calculator. You just have to type the word pi instead of the symbol. Okay, we good? It's not as bad as it looks. Sometimes it makes the answers look weird, but it shouldn't be confusing about what to type in. Okay, I know it looks strange when you do it, but it's fine. It's the same thing. Okay, we good? All right. Okay, so now it says the chain travels along the front and rear sprockets. The circumference of each sprocket is given. About how long is the chain? All right, so I know from here to here is 16 inches, and from here to here is 16 inches. And then the chain travels around the back of the sprocket there and there. So the orange stuff they gave me, that's 16. But the purple ones I've got to figure out, and those are basically the arc length that goes around the sprockets. We good? So we're going to start with the rear one. So for the rear sprockets, I know I'm doing arc length, so it's the measure over 360 is equal to L over 2 pi r. Well, did they give me the measure? What is it? Not of the rear one. 164. 164 over 360 equals, well, we're looking for the arc length, right? Did they give me the circumference? Yes. Like, I don't know what the radius is, but it doesn't matter. Nobody asked me for that. I knew the circumference anyway, so I'm good. So here is when definitely the numbers are bigger, right? I could probably start reducing, but I doubt any of us, besides 2, are thinking of, ooh, I know that divides in there. Like, don't even bother at this point. Instead, I know that L is equal to 8 times 164 divided by 360. But notice I didn't multiply because I don't have to multiply right now. I could start reducing this, but if there's a possibility that I could reduce the 8 out completely, I won't even have to multiply anything in the numerator. Does that make sense? So I'd start with the smaller one if possible. Now, 8 does divide into 360, but when I asked that earlier this morning, everybody was like, I don't know if it does or not. Well, instead of trying to figure out if it does, who cares, right? Is it pretty easy to divide by 4? Yeah, you divide it in half and divide it in half again, right? So let's take 360. When you divide 360 by 2, what do you get? 180. You divide it again, what do you get? 90. Okay, so I just divided that by 4. Well, I know 8 divided by 4 is 2. See how easy that is? Now, can I divide 90 by 2? Yes, 45. And then the 2 becomes a 1. So 8 actually does go into 360, 40. Oh, I put 48. Good Lord. Not 48, not 48. Let me fix that. 45. I had 8 on the brain there. So 8 actually does divide into 360. If you didn't know that initially, even trying to think about it or to do your long division, maybe it wasn't it easier just to do it and just do 4? And maybe 4 wouldn't have worked either, but that worked. Okay, so now I know for 45, it's divisible by 9 and 5, right? And so basically that means 3, 3, and 5 are my factors. I know 164 clearly not divisible by 5, right? But the only other option would to be maybe divisible by 3. Is it divisible by 3? No, because 6 plus 4 plus 1 is 11. So can I reduce any more? No. So I've reduced everything I can, and I get that the length is 164 over 45, and that's inches, and that is the rear sprocket. Don't you think that's better than actually multiplying 8 times 64 and then looking for factors? That's why I'm showing y'all that. Just learn how to make things easier on yourself. So now I have to go find the front sprocket. So for my front sprocket, I've already written down the formula right here, so I'm not going to write it down again. That arc measure is what? 196. So 196 over 360 is equal to the length over 22. Okay? So when I cross multiply here, I'm going to get L is equal to 22 times 196 over 360. All right, so I'm going to start with the smaller one again. So 22 would be 2 times 11, right? Does 11 divide into 360? No, but can I divide it by 2? Yes, so this is going to change to 11, and I'm going to change that to 180. So I've exhausted everything I can in that. So then I'm going to move to this one. Let's see if I can divide this by 4. What's half of 196? 98. And then what's half of 98? 49. Okay. So this is 49, so now I need to divide this by 4. 180 divided by 2 is 90, and that divided by 2 is 45. Okay, so now I'm left within the numerator 11 times 49 and 45 in the denominator. So again, I'm at the 9 and 5, so 3, 3, and 5. Obviously 11, I'm stuck. This is just 7 and 7, so can I reduce anything else? No, and I've reduced everything I can, right? So now, my length, I have to actually multiply in the numerator this time. 11 times 49. So what's 10 times 49? 490. And then I add one more 49 and I get what? 539 over 45. And see, once you get here, you don't have to try and decide, is it divisible anymore? I don't even know what the factors of 539 are. It doesn't matter because you've already done it before you made them the big weird numbers, okay? And you can't always not make them the big weird numbers, but when you can, you just make it easier on yourself. So I've got the front and the rear, okay? So these are things that I needed, these arc lengths here. And then what I'm looking for is the actual length of the chain. So what do I need to do now? Add them, right? So I'm going to take the two arc lengths, so this 164 over 45 plus the 539 over 45 plus what? 16 plus 16. Okay. Now, up to this point, I feel like the numbers that they gave you are fair game for a non-calculator question. Even this technically is fair game, but it usually doesn't get too terribly ugly. You can expect some weird fractions sometimes on non-calculator, but when it gets super big and weird, nobody's trying to torture you with them, but it also makes you start missing problems because of the stupid big numbers and not have anything to do with what you're actually finding. So most likely you would be, even if you wanted exact answers, be allowed to at least use a calculator. So I'm just going to give you this. But I do also want you to notice that at least we have a common denominator here, right? It's already there for me for those two. I would still have to get one here, but we're not going to worry about that. I'm just going to give it to you. So the length of the chain, because I know you're capable of it, we just don't need to waste the time doing that. The length of the chain is 2143 over 45 inches, which is 47.622 inches. And then I'll get out of the way so you can write it down. But I need the exact answer there, even though it does say about how long is the chain, which usually implies not an exact answer. But I wanted the exact one because we have a second part to the question. And anytime you use an answer you already found, you have to use the exact one, whether it's a fraction or it's something you have stored in the calculator. You never, ever use a rounded answer for anything because that just kills you on accuracy. All right. Right so far? Yes? Okay. So then here. Now this says on a chain, the teeth are spaced at half-inch intervals. How many teeth are there on this chain? So we're talking about the chain that we already know the length of. And I know that they're at half-inch intervals, so I want to know how many teeth are there on this chain. So I want you to think about how you might figure that out while I pass out the homework, and then we'll talk about it. Okay, so I've heard something, as I was walking around, I heard, well, I would just multiply by 2, or I would just divide by 2. And I kind of heard both, and then I heard some discussion. So do you ever get into a place where you're thinking about the problem and you're like, oh, I would totally just multiply by 2. Or wait, no, I would divide by 2. And then you start confusing yourself and you're not sure. And you know it's one of the two, but you don't know which one. And that doesn't do you any good because you got a 50-50 shot. All right, so instead of just anytime you can just do something like that, that means that there is a proportional relationship there. It gave you a rate. You need to learn how to read these and think about them that way. This says on a chain, the teeth are spaced in half-inch intervals. That means for every one tooth on the chain, there is 1/2 of an inch. It's a ratio, right? It's a relationship between the two. So it is a proportion. So as you think about that, you can think about, all right, well, I know that for every one tooth, so I'll just use T for tooth, for every one tooth, there is 1/2 of an inch. Well, I know how long the chain is. It is 2143 over 45 inches. So if there's one tooth for every half inch, how many teeth are there in this many inches? Does that make sense to you? So then it doesn't matter if you're thinking, I'm going to multiply, divide. You set up your proportion and you solve it. Y'all are good at them. Start trying to think about everything you possibly can as a proportional relationship, and it will help you tremendously. So now I cross multiply, right? I'm solving for x. So x is equal to, I multiply these two together, which is just 2143 over 45. And then I'm going to divide that by 1/2. So now I have a fraction and a fraction. Should I just like freak out and quit? No. The answer is no. Right. You're dividing fractions, so what do? Multiply by the reciprocal. Good. So this becomes 2143 over 45 times 2 over 1. So do I multiply the numerator and the denominator both by 2? No. All right. Plus, this does tell me all I really had to do was multiply by 2. But at the same time, y'all aren't always 100% sure. Sometimes you're like, yeah, that's it, and then you kind of get lucky that you were right because you weren't 100% confident. You just got it right. This lets you make sure you got it set up right. Well, all right, I can't reduce these. It'd be nice if I could, but I can't, so I know 45 has to stay down here. And then 2 times this would be 4286. So what are my units on this? Inches? No. Teeth. Which as a decimal would be 95.244 teeth. Now, you can't have part of a tooth, right? Well, I guess you can, but not on a chain most likely. But these answers, I have a really, really strong feeling that those circumferences that they gave us as whole numbers aren't really whole numbers, right? So there's some rounding errors somewhere, but it's all good. Okay. Now, we're not 100% done. Hang on. I want you to write something down at the bottom, and you may not have a whole lot of room at the bottom. I'm just have you write 2 sentences, but they kind of need to be together. So you might have more room at the very top. I don't know, but if you have room, You can write it on the front if you have room on the front. Just make sure it's not where you're going to, maybe at the very top at the front, wherever you can write 2 sentences, it's fine. So here's what I want you to write. I want you to write that arc measure is measured in degrees. Okay. And then I want you to write that arc length, arc length is a distance and measured in feet, inches, centimeters, etc.
Yeah.
Well, degrees are a unit too. So no. Yeah. So arc measure is measured in degrees. It's out of a 360. Arc length, think of it as a distance so that you're not getting them confused, because you could be asked for both things in one question and you have to know the difference between the two. Okay? Any questions at all? We good? Awesome. Go ahead and get it glued in.